This video is to help you with the final exam review, number one, the first CR for your final exam review. I do want to say it's really best for you to approach your teacher for support, to try to work through the problems yourself. These videos are just if you're struggling and you need some support, you go ahead and I help walk you through the problems. Also, I'm going to tell you, I don't have a calculator at home, so you're definitely going to want to check my calculations. So for the first one, it says simplify. 7 and 1/100 times 10 to the negative fourth times 5 times 10 to the second. All right, well, these numbers are in scientific notation. So I'm going to make an assumption that the final answer needs to be in scientific notation. Because what you're going to do when you get a simplified answer, one of the answers that you'll get won't be in scientific notation. And that, in some ways, is a beautifully acceptable answer, except I'm assuming your teachers want your final answer in scientifics. Okay, lot of talk. Let's get going. So if we want to simplify this, and we're trying to multiply two numbers in scientific notation, we go back to, we know, if we look at the tens, when you're multiplying with the same base, what do? When you're multiplying with the same base, you keep the base and you add the exponents. So that's what I'm going to do with the base of 10 here. I'm going to keep my base and I'm going to add my exponents. So I know part of my final answer, or working towards my final answer, will be 10 to the, we're multiplying, you're going to keep the base of 10, you're going to go ahead and add the exponents on each of those 10s. So it's negative 4 plus 2. So I know part of my answer will be 10 something times 10 to the negative 4 plus 2 is actually a negative 2. If integer rules are still uncomfortable for you, please use your calculator as a tool. Signs are different. I found the difference. 4 minus 2 was 2. I kept what I had more of. I have more negatives than positives. All right, so then we're going to look at our first factors. If we want to multiply two numbers in scientific notation, and we first take care of our exponent portion, I then take a look at my first factors, and all you're going to do is multiply those first factors together. So I'm going to multiply together 7.01 and 5. I don't have a calculator at home, so off to the side I'm going to do 7.01 times 5. You're going to double check my calculations because I'm not sure I'll be right. 5 times 1 is 5. 5 times 0 is 0. 5 times 7 is 35. Now, if I look at my original problem, I can figure out where the decimal point has to go, even if I can't remember if this is over 2, this needs to go over 2. Because 5 times 7 is 35, so my final answer has to be somewhere around 35. 35.05. Or you just remember, if that decimal point is over 2 places in the answer, your decimal has to be over 2 places. So if we didn't have to put this number in scientific notation, we would be done. This would be it. And we'd say, oh, yay, my final answer is 35.05 times 10 to the negative 2 power. We'd be like, yay, it's B. But no, I'm sure your teachers want it in scientific notation. So when you are given a number in which the first digit is not between your 1 and 10 for scientific notation, your teachers have probably taught you about your friend Lars or your LA notebook. What that says is that if you have to move the decimal point to the left, you need to add to the exponent the number of places you've moved it. So if I look here and I need it back in scientific notation, so that first factor has to be between 1 and 10. I go, 35 is not going to work. What's a number here that gets me between 1 and 10? Oh, 3.505. Now I have a number between 1 and 10 for my first factor, times 10 to some power. And I go back to my good friend Lars. If I have to move that decimal over 1 place to the left, that means I need to add 1 to the exponent on my power of 10. So here, if you know the decimal point moves one place, that's why I add 1. If I had moved 2 places, I would have added 2. If I had moved 10 places, I would have added 10. So negative 2 plus 1, oh, negative 2 plus 1 is a negative 1. Again, if you struggle with your integer rules, please be sure to use your calculator. But the signs are different. I find the difference. The difference between 2 and 1 is 1. What do I have more of? I have 2 negatives, only 1 positive. I have more negatives. So in other words, our final answer is letter A. I'm also going to say, if you're using these videos for support, if you just circle answers, your teachers aren't giving you credit for that. You actually have to show that you at least worked through the problem with me. All right, let's go on to another one. Let's take a look at number 2. It says rewrite 7 to the negative 2 power using a positive exponent and then evaluate the result. Okay, so in order to make a negative exponent positive, negative exponents don't represent negative numbers. They represent like teeny tiny distances. So it still will be a positive number in the end. It's just going to be a teeny tiny number. So negative exponents, if we want to make them positive, we need to take that negative exponent and do 1 over whatever the base is, stays the same, but then you can change it to a positive exponent. If you're given a negative exponent, you keep your base. So you add a base raised to a negative exponent. That's the same as 1 over keeping the base but making the exponent positive. So I'm going to do that for this example. If you have 7 to the negative 2 and your teacher needs you to write that using a positive exponent, you would do 1 over 7 to the second power. That's as a positive exponent. You can check that on your calculator. If you plug in 7 to the negative 2 on your calculator, you'll get some decimal. If you do 1 over 7 squared on your calculator, you'll get the exact same decimal. They represent the exact same number, and it's not a negative number. I can tell you they gave you A, they gave you D, because they wanted to see if you accidentally thought negative exponents meant negative numbers, and they certainly don't. They're teeny tiny distances. Okay. So now they want us to actually evaluate it. So if they just needed it as a positive exponent, we'd be done, but now they're asking us to evaluate it. Now to evaluate that, 1 over 7 squared simply means, oops, well that doesn't mean 7. Oh, it means 1 in the numerator over 7 times 7. That's 1 over 7 times 7 is 49. So the final answer would be letter B. Okay, I'm actually surprised they gave you that one. I would have thought 1 over 14 would have been one of the possible answers, but what else? It's totally letter B. Hopefully that helps on that problem. Pretty straightforward. Let's take a look at number 3. The equations of 2 lines are given below. So you're given a system of equations. 4x plus y equals 10. 3x minus 2y equals 13, and they ask, is 3 negative 2 a solution to the system of equations? You can either solve this system, or you could plug 3 negative 2 into each equation and just see if it works. That would be checking it in both solutions, or in both equations, and seeing if it works for both. I think I am going to do it both ways, because some kids will just take a look at this system of equations and decide to solve it. So as I look at this, probably the easiest way to solve this system of equations for me is to get my first equation solved for y and then substitute that into the second equation. So that's what I'm going to do. If I have 4x plus y equals 10, and again, as I work through this problem, if this method isn't comfortable for you, I am going to show you another method. I would first start by subtracting 4x on both sides to get y all by itself. 4x minus 4x, bye-bye. We have y equals. Now listen, my friends, you cannot combine these. These are not like terms. Think back to your X's and no's with Miss Pearson. So y equals 10 minus 4x. And we cannot shove those together. Those are not like terms. But now we used our first equation to find out what y was in terms of x. So I'm going to take that entire expression, 10 minus 4x. I know that that is actually the same as y. So I'm going to take 10 minus 4x and shove it in place of y in that second equation. So that's my next step here. So this is 2 times y. I just want to make sure everyone understands that. So in that second equation, I would now have 3x, because the second equation was 3x minus 2y equals 13. I solved my first equation for y, and now I get to shove 10 minus 4x in place of the y, substitute it in. So I keep my minus sign, I keep my 2. I know the operation between the 2 and y is multiplication, so I have to multiply 2 by this entire expression, actually a negative 2. But to show that I'm going to multiply by that entire expression, I put the 10 minus 4x in parentheses, I keep my equal sign, I keep my 13. So what I did, in place of the y, I shoved 10 minus 4x. I substituted that in. And the reason we do substitution for a system of equations is because then we get down to an equation with just one variable. Now we're going to deal with an equation that just has x's. We know how to solve equations in one variable. So if I'm going to solve this equation, I need to start by distributing the negative 2 through the parentheses. And so we have 3x, negative 2 times 10 is negative 20. Negative 2 times negative 4x, negative times a negative, that's a positive. 2 times 4 is 8x. Still equals 13. Then I'm going to combine like terms. 3x and 8x are like terms. 3x and 8x on the same side of the equal sign. You just combine them. 3x and 8x. 11x minus 20 equals 13. Now I'm just going to solve this just solve this now two-step equation for x. How do I undo subtracting 20? Oh, I add 20 to both sides. And I have 11x is equal to 20 plus 13 is 33. Divide both sides by 11, and I come up with x equals 3. Wow, I now know x equals 3. Now that I know x equals 3, I can substitute back in to any one of the equations to find y. I might actually use this equation that we solved. Y is equal to 10 minus 4x. I just found x to be 3. So y is equal to 10 minus 4 times, in place of x, I'm going to put a 3. Y is equal to 10 minus 12. Y is equal to negative 2. So I just found that 3 comma negative 2 is a solution. It's the only solution to both equations. It's the only ordered pair that when we substitute that ordered pair into each original equation will be true. It's where those two lines would cross if we graph them. So, yes, it's a solution to both equations. Now, if you did not like that method, I only have about a minute and a half left on this video. I'm going to try to show you what you could do, a way to just quick guess and check. So I'm going to take my original system of equations. I'm going to plug x is 3 and y is negative 2 in for x and y and check to see that it works in both equations. So let's do that. I'm going to take my first equation, and that is 4 times x, x is 3, 4 times 3 plus y, y is negative 2, and I'm hoping that will be 10. 4 times 3 is 12. 12 plus negative 2, is that 10? 12 plus negative 2, 12 minus 2 is 10. 10 equals 10. That tells me that is the solution to the first equation. Now, in the last 30 seconds, I'll try to prove that that point's also a solution to the second equation by substituting in. So I take my second equation, 3x minus 2y equals 13. I substitute a 3 in place of x, a negative 2 in place of y. 3 times 3 minus 2 times negative 2, and I'm hoping that's 13. 3 times 3 is 9. Negative 2 times negative 2 gets us to plus 4. I'm hoping that's 13. 9 and 4 is 13. 13 equals 13. That means 3, negative 2 is also a solution to the second equation. This is the work you